Have you ever watched the opening scene of Clueless? If not, then you missed out on Cher's closet giving her fashion advice. This clearly worked for her, considering the massive influence that Clueless had on 90s fashion. Still hasn't reached the mainstream market, but that doesn't mean it's not possible. In fact, we could probably recreate this with the help of AI and neural networks. At least, the first part, which involves identifying what kind of clothing something is. There's actually already a data set that we can use to train this kind of model. It's called the Fashion MNIST. It's a group of 70,000 photos. These articles of clothing can fit in one of 10 categories. T-shirt top, a trouser, a pullover, a dress, coat, sandal, shirt, sneaker, bag, or ankle boot. Let's take a look at one of the photos in this dataset. This picture is made up of 28 by 28 pixels, and each of these pixels is represented by a single numerical value. Each of these numbers is between 0 and 255 on the grayscale. To start building the neural network, we're going to have to do some data preprocessing, which involves dividing each of the numbers between the 0 and 255 by 255. This will help scale down our data to make it a little easier to work with. It's especially important when we have lots of different columns of data. So in this simple project, it's not as necessary, but it's still a good practice. So there are several different models that we could use to train this neural network. The two that I used were making a simple multi-layer perceptron and a convolutional neural network, or CNN. The CNN reached a higher accuracy than the MLP, so I'll be taking you through how you can create your own. CNNs were specifically designed to classify images. On a basic level, the model learns to recognize different features inside a photo, specific characteristics. The advantage that CNNs have over multi-layer perceptrons is that they can learn to identify these features in relation to each other. If we go back to that photo of a shoe, the model might learn to recognize that the shoe has a low-profile vamp, a diagonal sole, and then a heel. Let's say in this photo, we have the low-profile vamp on the left side and the heel on the right side. While a multi-layer perceptron might start to only learn that these shoes will have these features in this order, CNN can learn to recognize these features even if the photo is flipped or rotated. If we actually compare the CNN to a standard multi-layer perceptron, we can see that the difference lies within the hidden layers. In a CNN, we'd call them the convolutional layers. CNNs look through filters, or kernels, to identify these common features that show up in a particular class. In the first hidden layer, these might just be identifying very simple features like edge detection or corners. As we go deeper and make more hidden layers, simple features will start to be combined into more complex and nuanced features like the ear of a cat or the heel of a shoe. Let's return to their mechanism. Remember how these photos are made up of numerical grayscale values? The model will run through these numbers within their filter, which will help create a feature map. In the code, it might look something like this. We're going to be using a sequential model, which basically means that the information is going in through the inputs and is going out through the outputs. The number of filters, 32, actually corresponds with the number of nodes that are going to show up in the hidden layer. If you're wondering why 32, it's just a common general standard that we use in such neural networks, but you can trial and error and try other methods to figure out what the best number is. The ReLU function just reduces some of the computation time because it'll only accept values that come up as a positive number. Now we've created a feature map from that first layer, but there's still a lot of computation that needs to be done from this. We can reduce the feature map even more by using a pooling operation. We're just going to use max pooling, which will scan through the feature map, but it will only conserve the largest value inside of the filter. Then it'll move on to the next group based on a predetermined stride length, or shift. So since this is a pretty simple project, we don't actually need that many convolutional layers within our hidden layers. I'm just going to use 2 in this case. So once we finish with the hidden layers, we can move on to the last layer, or the output layer, which basically looks like a regular dense neural network. And it'll just have 10 output nodes, which corresponds with each of the 10 categories of clothing that we looked at. Here's how you're actually going to train the model. You can run the code. I'm going to train it on 10 times speed, but it usually takes about 45 seconds. And you can see the accuracy is actually about 92%. And then if you type in a random number, it'll generate a random photo, and you can see that the model actually predicted it was right.